Okay, so today we're talking about surface area and volume of prisms and cylinders. And let's talk just a minute about what surface area is. Okay, surface area is basically the area of every surface that's open to air. Okay, so if I were going to take contact paper or tissue paper and cover every flat surface, that's what surface area is. And ultimately, to find surface area, you could go and find the area of each piece and add them all together. I'm going to show you some formulas that make it a little bit quicker and easier, okay? Volume, and surface area is in square units because it's area. Volume is how much goes on the inside. If you were going to fill it up with grain or water or whatever, okay? It's in cubic units, okay? So surface area is in square units and volume is in cubic units. We're going to talk about surface area first. A couple of things we'll just review from yesterday. Remember, you have bases, and those are your congruent faces in parallel planes. Like in this triangular prism, my two triangles are my bases. We have lateral faces, okay? Those are the faces that make up the sides. In this case, there's three of them, right? Lateral faces. Then we have lateral edges. And lateral edges are where the lateral faces intersect. So, like right here is the lateral edge, and it's the intersection of this lateral face and that lateral face, okay? And the thing about the lateral edges is that they are parallel to each other. Okay, so these are parallel to each other, these lateral edges. Now, one thing we didn't talk about yesterday was the height. And that is a segment that is perpendicular to the planes containing the two bases. So it is a segment that's perpendicular to both bases. In a right prism, which is what we're going to primarily deal with, your lateral edges also act as altitudes. Okay, those edges are going to be perpendicular to both bases. Now, a right prism, like I said, the lateral edges are also the altitudes, as opposed to an oblique prism. An oblique prism is one in which the bases, one's not right on top of the other, it's kind of slanted. You still have lateral edges that are parallel to each other, but then your height has to be dropped outside and the base has to be extended, right? But like I said, we are going to deal with right prism. Okay, now, to find surface area, there's what's called lateral surface area and total surface area. Okay, lateral surface area is the sum of the areas of all the lateral faces. Well, like I said, you can go and find the area of each one of them and add them all together. Or you can follow this formula where it's the perimeter of the base times the height of the prism. Perimeter of the base times the height of the prism. Your total surface area, which some folks refer to it as T, some refer to it as SA. Okay? That is the sum of the lateral areas and both bases added together. Alright? And so that formula is the lateral plus 2 times the area of the base. Now, area of the base takes on whatever shape the base is. So if it's a triangle, you use the area formula for a triangle. You know, if it's a rectangle, you use it. If it's a pentagon, you use that correct formula. Okay? But it's the lateral plus 2 times the area of the base. Here's a more extended version where instead of L, I put PH, which is perimeter of the base times the height plus 2 times the area of the base. Alright, so we want to find the lateral area and the surface area of the prism. Now, one of the most important things that are two really important things. I highly recommend that for every problem you write the formula down. Let me tell you why. Because you need to write that formula down, okay? Inevitably, I'm working along, okay? I find the area of the base, I forget to fill it, okay? And if you have it up there, because all these formulas are different, you don't want to forget a piece of the formula. So if you've got that formula written down on the problem, it's going to be less likely for you to, leave out a part of it. The other thing is with these prisms, you have to identify what the base is, okay? And remember, the base are congruent polygons that are parallel to each other. This one, what's going to be the base? First problem here. What shape is the base? It is a triangle. It is actually laying on its lateral face. And so when you're finding these pieces, it's really important to identify that the triangle is the base. So for the lateral, it is the perimeter of the base times the height of the prism. So my base is a triangle, so I've got, and it's a right triangle. One leg is 3, one leg is 4. I need the hypotenuse. What is it going to be? It's 5. Okay. So my perimeter to be 10. It's going to be the length of that lateral edge. Okay, so the lateral surface is 120 meters squared. Now, my total surface area is the lateral plus 2 times the area of the base. We already found the lateral will be 120, and it's going to be 2 times whatever we find the area of the base to be. And remember, we said it was a triangle, right? What's the formula for the area of a triangle? Base times height divided by 2. What are my base and my height? 4 and 3. So that's 12 divided by 2, which is 6. So the area of my base is 6, but then I have to double it because there's 2 of them. So I get 120 plus 12, which is 132 meters squared for my surface area. Okay, now the next one is the surface area of a rectangular prism. Now there's a formula that's not on your paper that a lot of times they use on the EOI, and it is 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Okay, and that'll give you total surface area. It won't give you lateral, but it will give you total. Okay, so you can use it, or you can use the one that we just talked about. Okay, now again, one of the more important things for you to identify is what the base is. In a rectangular prism, some of you like to use what's facing you as the base. I like to use what it's actually sitting on. Okay, and so the base that it's actually sitting on is this 15 by 11 base. Okay, so if you wanted to find the lateral of the base times the height of the prism, well, my base is a 15 by 11 rectangle, so that's 2 times 15 plus 2 times 11, that's 30 plus 22, that makes the perimeter 52. So that's 52 for the perimeter, and then what's the height? 10. And so the lateral ends up being 520 meters squared. Now, let's say that your friend wanted to use the 10 by 15 as the base and 11 as the height. Okay? Your lateral surface areas will be different. Your total surface areas will be the same. Okay? Alright. So now we want to do the total surface area. And so that's lateral plus 2 times the area of the base. We already found the lateral to be 520. And then my base is a rectangle, so that's 15 times 11. Which is 165. So you gotta multiply it by 2, because there's 2 of them, which is 330. So we get 520 plus 330, which is going to be 850 meters squared. Any questions on what I did there? Now, before I go on, let me show you this other formula. Okay? If you want to use this, and you just need the total surface area, you need to identify the length, the width, and the height, and you can plug it all in. So this would be 2 times 15 times 11 plus 2 times 15 times 10 plus 2 times 11 times 10. And so that would be 30 times 11, which is 330, plus 15 times 10, 150 times 2 is 300, and then 20, which is 220. Add those together, and you get 850. So there's another formula. That only works for the rectangular prism. Okay, and it's on the formula sheet, and I think that's what they give you on the EOI. Either formula works, okay, so whatever you're more comfortable with. Alright, now let's look at the cylinders, okay? Just to review, and one thing that we did not talk about yesterday was what an axis was. Okay, you got your 2 bases, and in a cylinder they're both circles. congruent and parallel to each other. The axis is a segment whose endpoints are the center of the circle. So it's a segment that goes from one center to another, okay? One center to another. So this right here is the axis on this one, and here this is the axis on the oblique, okay? Now we're going to primarily work with the right, and in the right, that axis also acts as the altitude, or the height, okay? In the oblique, they're two different segments. All right. So, the lateral for a cylinder is the circumference times the height. And remember, circumference is pi times the diameter. And then the height is the height of the cylinder. The total surface area is just like that for a prism, the lateral plus 2 times the area of the base. Now, you can be a little bit more specific. Your formula here, you can do pi times the diameter times the height plus 2, and the base is always a circle in a cylinder, pi r squared. So you can be a little bit more specific there. In the prism, the area of the base takes on whatever shape it is. This one is always a circle. All right, so we want to find the lateral area and the surface area of the cylinder. So remember, the lateral is pi times the diameter times the height, or circumference times the height. What's my diameter? 12. So that's 12 pi times the height, which is 14. So we're going to do 12 times 14. That's 168 pi. That would be my exact answer. And that's important to keep hold of that because we want to use that when we go to find the total. But the estimation would be 527.8 centimeters squared. Now we want to do the total. Okay, and the total is the lateral plus 2 times the area of the base, which is pi r squared. So my lateral is 168 pi, and then what's my radius? 6. So if I plug that in here, 6 squared is 36 times 2, which is 72 pi. So we have 168 plus 72 is 240 pi. That would be my exact answer. Okay? You guys need to be showing me all these steps, especially on that test. Because, you know, a lot of people had a bunch of just gibberish down. I couldn't tell what in the world they were thinking, so I couldn't give any partial credit on the test. Okay? All right. So 240 times pi gives me 753, actually 754 centimeters squared. All right. Now this one works backwards. This one wants us to find the height of the right cylinder if the surface area is 192 pi centimeters squared and the radius is 6. Okay, so we want to, it gives us the total, which is the circumference, pi times the diameter, times the height, plus 2 times the area of the base. There's my formula. Okay, I'm going to write my formula down. Now I want to go and plug in everything that I know. I know that the total surface area is 192 pi, and I know that the diameter is what? 12. So that's 12 pi times the height. And then the radius is 6. So again, this would be 36. 6 squared is 36 times 2, which is 72 pi. Now I'm going to find out what h is. What might make my life easier? Divide everything by pi. So I end up with 192 equals 12h plus 72. Subtract 72 from both sides. That gives me 120. 120 equals 12h. Divide both sides by 12, and the height is going to be 10 centimeters. Questions on what I did there? Okay, now let's do volume. Volume's a little quicker. Surface area to me is kind of time consuming. Okay, so we're going to talk about the volume of prisms and cylinders. Remember, the volume is the amount of space that a figure encloses. It's how much goes inside of it. If you're prism and the cylinder is the same. It's the area of the base times the height. And again, the area of the base takes on whatever the base shape is, okay? And then the height is the height of the prism. Now the rectangular prism has kind of its own special one. You can still use this one, but this one's a little quicker, and I think that's what they give you on the EOI, which is length times width times height. Okay, and that'll give you the volume on a rectangular prism. Which really, if you think about it, area of the base is length times width times the height, right? So it's really the same formula, it's just a little bit more expanded. Okay, so we want to find the volume of the prism. Okay, and being a rectangular prism, we can do length times width times height. And so my length is 7, my width is 3, and my height is 4. So it'll give me 21 times 4, which is 84, is that right? 84 centimeters cubed. Now we're in volume, so it's in cubic units. And I will tell you that on your test, some of you did not label your answers, and I was very generous. Some of you got a really good grade, but it would not have been so good if I had counted off for not labeling correctly. So really try to make sure that you do that. All right, here is a triangular one. Okay, a triangular prism. Volume is the area of the base times the height. What's the shape of my base? Okay, it's 30, 60, 90 degree triangle, right? An area of a triangle is base times height divided by 2. Now I need to get all my pieces here that I need. I can transfer this 12 feet over to here, okay? So I've got a 30, 60, 90 triangle where I know the hypotenuse. Okay, what can I find if I know the hypotenuse? The short. Now where is the short? It's across from the 30, right? Always, no matter what it looks like, it's always across from the 30. There was one question on the test, and it was really kind of hard to see which one was longer. And some people, they got them mixed up. No matter what the picture looks like, the short is always across from the 30. Always, okay? All right, so it's half, which would be 6, which means the long is going to be 6 radical 3. So base times height divided by 2, we get 6 radical 3 times 6 divided by 2. Okay, which is 36 radical 3 over 2, which is 18 radical 3. So the area of my base is 18 radical 3, and then the height, what's the height of my prism? 15. Remember, it's the lateral edge, okay? So that's 15. So we multiply that, 18 radical 3 times 15, which is 467.7 feet cubed. That's its volume. All right, and here's a tricky one. Since prism A and prism B have the same length and width, but different heights, if the volume of prism B is 150 cubic inches greater than the volume of prism A, what is the length of each prism? Okay, so we're wanting to know what the length is. Now we know that they're the same, so I can let X represent the length of both of those, yes? Okay, and it says that we go ahead and find the volume, length times width times height. So what's that going to be in this one? 28x, right? That's my volume. And this one's going to be length times width times height is 40x, right? But it says up here that the volume of B is 150 cubic inches greater than A. So they're not equal to each other, but what could I do to make them equal so I can set up an equation? Add 150 to this one, right? Because this one's 150 more, so if I add 150 to this one, they'll be the same, yes? So if I take the volume of the smaller one and add 150 to it, it's going to be equal to the larger one. And so now I can solve for x and find the length. So that ends up being 150 equals 12x. Divide both sides by 12, and x ends up being 12.5 inches, which is the length. Questions on that one? All right. Done? with a cylinder, same formula, area of the base times the height, except the area of the base is always pi r squared, right? So it's pi r squared times the height, and that's the height of the cylinder. So we want to find the volume, pi r squared times the height, and it gives me everything that I need. What's my radius? 3. So it's pi times 3 squared times my height, which is 4, right? So 3 squared is 9 times 4, which is 36 pi, correct? And so if I plug that in, I end up with 113.1 centimeters cubed. Okay, here's the last one. That was just a little note. This one's a little tricky though. It gives me the diameter, but it doesn't give me the height. It gives me the segment that goes from one corner to the other. This is my height, which I don't know, and then it gives me the diameter. What's created right there? A right triangle. Okay? And so what would I do to figure out the Pythagorean theorem? So I'm going to do x squared plus 10 squared equals 13 squared. X squared plus 100 equals 169. Take the square root, radical 69 is my height. Okay? So we come back over here, my volume is pi r squared times the height. What's my radius? 5. So that's times 5 squared times the height, which is radical 69. So I can just plug all that into my calculator. Pi times 5 squared is 25 times radical 69, which is 652.4 centimeters cubed with volume. Questions on any of those? Alright, one last little note here. It says to find the volume of an oblique prism or cylinder, you just use the same formula. You just got to make sure that you use the perpendicular height. So, like, if you come back over here, well, if it happened to be like oblique, you would have to use the perpendicular height. Okay, you still do the area of the base, but you would have to use that perpendicular height. Okay? Any questions? All right. You have your workbook pages.